Good evening. I am Professor Shalini Sahay, Assistant Professor in EC Department, SIRT Bhopal. In this lecture, I am going to discuss about the microwave components. First, we'll discuss what is microwave. It is a form of electromagnetic radiation with wavelengths ranging from about 1 meter to 1 millimeter with frequencies between 300 megahertz, that is 1 meter, and 300 gigahertz, 1 millimeter. Different sources define different frequency ranges as microwave. The above broad definition includes both ultra-high frequency and extra high frequency millimeter wave bands. Some of the microwave components have the following functions which we have discussed in the following way. First, the function is to terminate the wave, split the wave into paths, control the direction of the wave, switch power, it will reduce the power, it will sample the fixed amounts of power, transmit or absorb fixed frequencies, transmit power in one direction, and shift the phase of the wave, detect and mix waves. So the main functions of the microwave components is to control the power, absorb the frequency waves, and detect the mixed waves. Now we'll discuss some coaxial components which are like as connectors. Microwave coaxial connectors require to connect two coaxial lines that are called as connector pairs. These are of two kinds, male and female. They must match the characteristic impedance of the attached lines and be designed to have minimum reflection coefficients and not radiate power through the connectors. For examples, these are some kinds of the connectors. Now, coaxial sections. Coaxial line sections slip inside each other while still making electrical contacts. These sections are useful for matching loads and making slotted lines measurements. Double and triple stub tuning configurations are available as coaxial stub tuning sections. Now we'll discuss about the attenuators. The main function of an attenuator is to reduce the power of the signal through it by a fixed or adjustable amounts. The different type of attenuators are fixed attenuators, step attenuators, and variable attenuators. Now we'll discuss some of the waveguide components. These are generally as directional couplers, T-junctions, attenuators, impedance changing devices, waveguide terminating devices, slotted sections, ferrite devices, isolator switches, and circulators. Now we'll discuss about the attenuators in more detail. Attenuators are components that reduce the amount of power, a fixed amount, a variable amount, or in a series of fixed steps from the input to the output of the device. They operate on the principle of interfering with the electric field or magnetic field or both. Slide wind attenuators. They work on the principle that a resistive material placed in parallel with the E lines of a field current will induce a current in the material that will result in I square R, that is termed to be as power loss. Now the flap attenuator. A flap attenuator has a vane that is dropped into the waveguide through a slot in the top of the guide. The further the vane is inserted into waveguides, the greater the attenuation. Rotatory vane attenuator. It is a precision waveguide attenuator in which Attenuation follows a mathematical law. In this device, attenuation is independent on frequency. Now we'll discuss about the isolators. Mismatch or discontinuous causes energy to be reflected back down the line. Reflected energy is undesirable. Thus, to prevent reflected energy from reaching the source, isolators are used. Faraday rotational isolator. It combines ferrite material to shift the phase of an electromagnetic wave in its vicinity and attenuation vanes to attenuate an electric field that is parallel to the resistive plane. Now, resonant absorption isolator, a device that can be used for higher powers. It consists of a section of rectangular waveguides with ferrite material placed halfway to the center of the waveguide along the axis of the guide. Thank you.